Hi everyone, this is calculating gram formula mass and percent composition. We're going to start with formula mass first. This is also called like molar mass. We're just doing it of a compound. So you guys already know how to look up the molar mass of an individual atom. It's on the periodic table. It is the decimal number. This periodic table might be different than the one you have. You always want to use the entire number from the periodic table. So your answers might be slightly different than mine because you've used a different periodic table. Okay, so what I like to do is just sort of in the margins write out each element and then multiply it by however many I have. So in number 4, I'm going to do number 4 as an example. I have 1 calcium. Let's see, I have nitrogen, and I have these parentheses here tell me that 2 distributes to everything inside of the parentheses. So that means I have 2 nitrogen, and it means oxygen. I have 3 here times the 2, so I have 6 oxygen. So I'm going to go ahead and look up the molar mass of calcium. It says down here it's 40.08. So 40.08. The molar mass of nitrogen is 14.01. And I'm going to multiply that by 2 because I have 2 of them. And then oxygen says 16.00. And again, I'm going to multiply that by 6 because I have 6 of them. So I'm going to go ahead and multiply those out. That's still going to give me 40.08. That's going to give me here 28.02. And for oxygen, 96.00. So I'm going to go ahead and add these all up, and I get 164.10. Again, the units for that, molar mass, grams per mole. So that is my molar mass for calcium nitrate, 164.10 grams per mole. You always want to use as many decimal places as you can. Because we use molar mass as a conversion factor. Just as a side note, if I'm going to go down and convert moles, so if I have like 5 moles of calcium nitrate and I wanted to convert that into grams, I would say 1 mole equals, I forget what the number was now, 164.10 grams. So there is my grams per mole unit. And then I would multiply and get an answer. So we use molar mass as a conversion factor. That's why it has 2 units, grams per mole. So it's either 164.10 grams per mole or 1 mole per 164.10 grams. So we use the conversion factor either way. When you are doing your mole conversions and you have the mole here and you're finding mass and you're using like the periodic table, the molar mass, or if you're finding molecules and then you're using Avogadro's number, 6.022 times 10 to the 23rd, this is the number you will use when you're converting from mass to moles or moles to mass. You will use the molar mass from the periodic table or the formula mass. So you'll be adding up, all elements within the compound. I wanted to do one of these, so I'll do number 7 that has that multiplication sign in the middle. Basically what that means is this is copper sulfate. I have 1 copper sulfate. For every 1 copper sulfate, I have 5 water molecules. So the counting is what's going to be important there. So I'm going to first list everything like I did before. So I have copper, and I have 1 copper. I have sulfur, and I just have this 1 sulfur here. Then I have oxygen. So I have oxygen, and I have 4 oxygen here. And then I have 1 here, but this 5 as a coefficient distributes to both of those. So I actually have 5 oxygen here and 4 oxygen here, which gives me 9 altogether. And then hydrogen, I have 2, but again that 5 distributes, so I actually have 10 hydrogen. So I'm going to go ahead and look up all those individual masses on the periodic table. So copper here is 63.55, 63.55. and then I'm going to multiply that by 1. Sulfur is 32.06. Again, I'm going to multiply that by 1. Oxygen is 16.00. Multiply that by 9, and then hydrogen is 1.01. I'm going to multiply that by 10. Again, you're going to use the masses that you see on your periodic table. It might not be the same as the masses here. That's okay. Just use every single decimal that you can. So now I'm going to multiply these out. So this stays 63.55. This stays 32.06. 16 times 9 is 144.00. That's a point. And 1.01 times 10 is 10.10. Okay, so again, I'm going to add all these up, and I get 249.71. So my answer here is 249.71 grams per mole. So that's formula mass of a compound. Please let me know if you guys have any questions on that. We are also going to go through how to calculate percent composition. So you do have to know how to do formula mass in order to do percent composition. So I highly suggest you pause the video, you do the molar mass worksheet, the gram formula mass worksheet, and make sure you have those correct answers. Then you can come back to the video and do the second part, percent composition. So for percent composition, first thing you're going to have to do is identify each of these elements. Since we haven't learned naming yet, you are going to have to look up what they are. So nitric acid is HNO3. I'm just doing 1A here. Nitric acid is HNO3. So first thing I need to know is the mass of the total compound. So gram formula mass, what we just did. Hydrogen, I have 1, nitrogen, I have 1, and oxygen, I have 3. Hydrogen is 1.01, nitrogen is 14.01, and oxygen is 16.00, and then we multiply that by 3. So those all become 1.01, 14.01, and 48.00. Okay, so I'm going to add those up, and I get 63.02. So that's the mass of the entire compound, but it is asking me to determine the percent composition of each element. So what I'm going to do for each element here is I am going to take the individual mass of the element. So for hydrogen, that's 1.01, and I'm going to divide it by the mass of the total compound, so 63.02, and then multiply it by 100 to make a percent. So I'm going to go ahead and set all these up first, and then I'll go through and put them in the calculator. So for nitrogen, that's 14.01 divided by 63.02 times 100 to get a percent, and then oxygen will be 48. You want to take all of the oxygens together, divided by 63.02 times 100. So I'm going to put that into my calculator, the hydrogen one. And for hydrogen, I get 1.60. I'm just going to do 2 decimal places since I don't really have sig figs given in this problem. Nitrogen is 22.23% nitrogen, and oxygen is 76.17% oxygen. Just to double check yourself, percents are out of 100, so you should be able to add all 3 of these together and get about 100. So just 76 plus 22, that's 86, 96, 98, plus 1 more is 99, and then if you take all these and add them up, you're going to get pretty close to 100. So that's how you know you did it correctly, is you should be able to check yourself, and they should all equal 100. So these are my 3 answers for this problem, 1A. Go ahead and continue the rest, and please let me know if you guys have any questions.